Hi everyone, I'm back with another practice example. Here we are asked to find the equivalent resistance of the circuit at RAB and then solve for the current I at the location that is shown here and that the power dissipated at 12 ohm resistor. Okay, so let's go step by step. When we look at the circuit, the most complicated part is this guy, this one, because no two resistors are in series or in parallel. This 10 ohm and 15 ohm are not exactly in series because one branch is going out from them, stopping them from being in series, and this 10 ohm and 10 ohm are not exactly in parallel because they have a 10 ohm in between them. So that's why, and this is the most complicated and equivalent resistance problem can get, is to use the star delta transform. Okay, at the end of the exam, usually you are given basically this cheat sheet, this one. You can see that you can replace a delta or a star, a delta by a star one, or vice versa, as long as you can relate the two sets of resistance by these formulas. Okay, so let's go back to our problem and see what we can do. So the problem we were solving was this one. Okay, so here, if I replace this delta one by a star one here, that would make it simpler because then these two and these two can be related to each other. So let's draw that. Let's say we have a 5 ohm here. We have, let's call this one R1. We have an R1 here. We have an R3. We have an R3. And then after R2, we have 15 ohm here. We have an R3. And then another 15 ohm here. And then this point. And then we have 12 ohm here. So all we need to do is to find R1, R2, R3. Okay, so let's go back to our cheat sheet. So when we want to calculate R1, R2, R3, we have to use these formulas. So here, simply, in the denominator, we have the summation of all three. And then Z1 in the numerator, we have the two resistance get multiplied. But which two? For example, for Z1 is connecting ZB and ZC. It's between ZB and ZC. So it has to be the multiplication of the two. For Z3, it's going to be ZA multiplied by ZB here over the summation. So that's how we can remember this. Or you can just, keep going back and forth between the cheat sheet. So let's go here. So for R1 is between the 10 ohm and the 10 ohm here. So it's going to be 10 multiplied by 10 by the summation of all the three resistance. We replace this guy, and then this guy. So 10. So all of them simple. So it's going to be 3.3 ohm. Because all of them are the same, so this is going to be easy. It's going to be 3.3 ohm. Right? Okay. So R1 is going to be 3.3 ohm. This is 3.3 ohm. 3.3 ohm. Perfect. Now we are looking into here. We want to find RAB. A, this is B. Okay, let's simplify that again. So the total one, we can see already RAB is this 5 ohm in series with whatever we can see from this point. Let's call this R prime, whatever. So 5 ohm plus R prime. What is R prime? R prime is actually whatever this guy is. Oh, let me use another color. Whatever this total resistance is in parallel with 12 ohm. So 5 ohm plus 12 ohm in parallel with the red one. I'm going to call it R double prime. Let's move on. Let's go. Then we have again 5 ohm plus 12 ohm in parallel with. And then R double primed is R1 in series with R2 plus 15 ohm in parallel with R3 plus 15 ohm. So first we calculate the parallel of the two, then we add R prime to it, then we make that in parallel with the other one. Okay, since R2 and R3 are exactly equal, the parallel of two equal resistors is the value of any of them over 2. So this is going to be 18.3 over 2, which is going to be 9.15 ohm. Now R prime is 3. Oh, sorry. This is R1. This is how I make a mistake. This is R1. Good job for everyone who caught this. So R1. So then we have 9.15 or 3.3 plus 9.15. That's going to be 12.45 ohm. Now 12 ohm is in parallel with this, so it's going to be 12 multiplied by 12.45 over 12 plus 12.45. Because they're very similar in value, I'm guessing it's going to be 11 point something. I don't know. Let's do the math. Oops. Let's do the math. Hopefully, in order for the math to work, I have to clean this up a little bit. So 45. So I know it's going to be 11, or I know that it's less than 12 because the parallel of two resistance is, no, I didn't understand. The parallel of two resistors is basically less than each of them. I don't know why. Let's say it's 11.8. Okay. And then we have 5 ohm plus that. I can do the math quickly, but anyway. So 11.8, 16.8 ohm. Okay. And then I really want to know the value of this because it might cause us. Okay. Okay, never mind. Forget about it. So we can say 12 multiplied by 12.45 over 12 plus 12.45. Okay, so this is our total equal resistance. Okay, then says solve for the I at the location shown. Okay, how do we find I? I is here, right? We said I, in order to find I, we have to go back to the circuit. So how much was the voltage at the source. It was 100 volt. Okay, so we had 100 volt. We had a 5 ohm here. We had an R prime. R prime was about 11.8 ohm, right? So in order to find I, all we need to do is to say I is equal to 100 volt over 5 plus 11.8 ohm. Or we can say I is 100 over R equal. So that's going to be 100 over 16.8 ohm. Let's see if it understands this one. So 5.95, 5.95, 5.95 amp. Now it's asking what was the power dissipated in 12 ohm. Okay, now it gets interesting because in order to find the power dissipated in 12 ohm, P at 12 ohm, we need to say 1 over 2 R I of 12 ohm squared. So 1 over 2 multiplied by 12 I of 12 ohm squared. So we need to find I of 12 ohm, right? We know the total I is about 5.95, but then this one, if you remember, we had a 5 ohm here, we had a 12 ohm here, and here we had what we called R double prime, right? So we have R double prime here, and then this is our I. We want to find how much I of 12 ohm is. So how much was R double prime? That's why these values are really important. R double prime was the total of the green one, which is 12.45. So here we have 12.45 ohm. So I of 12 ohm, this is like a current division, is going to be 12.45. The other resistance value over 12 the summation of the two resistance multiplied by I. So it's going to be 12.45 over 20.4.45 multiplied by 5.95, which is going to be it doesn't understand the dots. Okay, so it's about almost half, let's say. Okay, so this is about half. 5.95, it's going to be 2.98, let's say, amp. So this is our I 12 ohm. Are we done? Not yet. Then, in order to find the power dissipated in 12 ohm, P12, we go back. We say 1 over 2, 12, 2.98 to the power of 2. That's about 3. 6 multiplied by 3. 6 multiplied by almost 9, let's say, 54 watt. Again, this is almost. So that's how we find the power. I hope you learned something. Thank you for watching.